Welcome to Exponential Function Word Problems. If you prefer to read all by yourself, please pause this video, then come back, join the discussion. The first story is about Green Village. Green Village has 1,234 people to start with. Then every year the population grows, and here is the rate. It grows at a rate of 1.5% each year. Ask us to write the function to model the population after t years from now. So we're going to say we're going to write the number of the people, and the input is the time. As time grows, the population, the number of people grows. Equals what? Let's think about our form is y equals a times b to the x power. This is our exponential function form. A is initial value. B is the constant rate. So the constant rate here says it grows at a rate of 1.5%. However, remember, it grows like this. People times 1 plus, then you grow 1.5%. And then the next year, you're going to have the previous year. And times another 1 plus 1.5%. And then you just keep going like this. You always put down the previous year's, the number of population, and then you times 1 plus 1.5%. For this reason, we're going to write n of t is, we begin with the number 1, 2, 3, 4. We times open close parenthesis. You can finish writing what is 1 plus 1.5%. You move the decimal point to the left 2 times. Let me erase this, make it better looking for you. You move it 2 times to left side. You have 0.015. And then you add 1, so you're going to times 1.015. T years, put t as your exponent. That is for the first story, Green Village. Let's look at the next story. Next story is about the place where I'm from. That is a desert called a Tengger 沙漠. Tengger 沙漠, Tengger Desert. It is in Inner Mongolia. Of course, the data here is a made-up data. It says we started with 100 camels. Now, the population of camels is increasing. Wonderful. It's also increasing. We want to see more camel friends. And at a rate of 30% per year. Right, a function gives camel population t years from now. If you truly understand what happens to the Green Village, you can write for the camel. So camel, number of camels, or you can say population of camel of t years is, we start with 100. And every year will grow by 30%. So we're going to say 1 plus 30%. You can leave it as it is. You can say 30%, move it once, move it twice, and stop. That's 0.3. Add 1, that is 1.3. Okay? And the t years, you can put a t here. So let's write another one. You can write down like this. All right? Okay. Now, let's look at our third problem. Our third problem this time is not grow at a rate of, earlier it's at a rate of, this time it is growing by a factor. So Mrs. Gordon's fitness club had 20 members. Each year the club member increase. We like it to increase. Now, by a factor of approximately 2.2, we're going to write a function that gives number of the members after t years. So number of the members After t years, t is our input. As time grows, the number of the people who do exercise grows. That's good news. Wonderful. How many do we start with? We start with 20. This time, since it's a factor already gives us the constant rate of change, which is a constant ratio. And the ratio is 2.2. You can say times 2.2 after t years. If you say, I feel there are too many dots here, you definitely can write like this. All right. Now, this short video teaches us to tell the difference between the factor. When we have the factor, we directly put a factor at this place. What place? I mean y equals a times b to the x power. If you have a factor, you directly substitute the factor for b. If you say words like this, increasing or decreasing at a rate of 30%, increasing or decreasing at a rate of 1.5%, you need to add the 1. All right, I hope you have enjoyed today's learning. And let's see what Buttercup is doing. That's what she's doing whenever I'm teaching, and she hasn't missed any class, and she attended all of my classes. Good job, Buttercup, and thank you. I hope you have enjoyed today's learning.